Welcome back to the channel. We're back on the 8-horse mogul project. Springtime here, but getting kind of busy outside, but back in the shop today. And as you can see, I've been painting some mixer parts. And today we're going to make a spring. This is a small light duty spring that's on the governor linkage. It keeps the governor linkage tensioned against the governor, so any play is not seen by the butterfly linkage, so it makes it so the engine runs really smooth. So this is a torsion spring. It's very similar to what's on a mousetrap. It's not nearly as powerful as a mousetrap spring, but it works the same way. It kind of twists up. So we're going to be making that, and we'll be using the closing lathe to make that, and using spring wire. This is spring wire, it's music wire. It's available in different sizes, and it comes in a box similar to this. This stuff is very stiff and pretty dangerous when you take it apart, so I've got to be careful with that. The spring wire of today is a lot better than what it was back in 1914 when this engine was made. So you have to be careful about what size you use, and typically I try to use one size smaller than what the spring is that I'm replacing, because if you make it out of the same size, it will most likely be too strong. So we're going to start with that and see how the spring turns out. So I'll bring you in here a little closer and show you what this spring actually does. So here's a close-up of that linkage. This is on the butterfly shaft, throttle shaft that we made in the last video. I put it in here just as kind of a mock-up so you can see what it does. I have a taper pin in here, which is the correct way for it to be mounted. It was mounted in the other one with just a cotter pin, but that's not right. Should be a taper pin, so I got that in there. And this spring winds against this pin and then the bottom of the taper pin. So it winds it, holds this linkage back, and puts tension on the governor linkage. And like I said, just keeps the play out of the linkage mechanism. So this is what's left of the spring that I had. You can see it's just a tight wound coil. So we're going to make that spring on the lathe, and hopefully make a spring that we can use. Got the mandrel chucked up in the lathe here. I don't know what happened to the footage of making this mandrel, but I lost it somehow. There's a hole in the mandrel. That's what we're going to put the wire in. That wire needs to be held in place, and this hole does that. And then I'm going to put a little bend on the back of it so we can put some tension on the wire. Without that bend, it would just pull it right back out of the mandrel. We wouldn't get a wrap on it. So we're going to put a fair amount of tension on this, and we're going to do that with the tool post holder, and we'll get to that here in just a second. So here we are getting ready to make a spring. So I'm going to use a couple of pieces of wood. In this case it's oak. You can use plastic or brass, or something soft like that, but these oak boards I think will work out pretty well. I'm going to put them in the quick change tool post holder and get them set to about the right height so that they're right in line with that hole that's in that mandrel. I'm going to run the carriage over, and I'm going to put the wire in the tool post holder about in the center of those wood blocks, and there's what I'm going to try to do. It's not necessary it needs to be in the middle, but it does make it a little easier to control, and then also it puts the tension that I'm going to put on it right on top of the wire. So I'm going to run the carriage over here a little bit and get it about in the middle so that when I tighten those screws down, it's putting the force right on the top of the wire. So then I'm going to put the other board in right on top, so I've got it all sandwiched together, and then I'm going to put a little tension on it with those screws. And how much tension? Well, just kind of go by feel. You want enough that it stretches it, pulls it good and tight, so you got good control, but not so much that it'll break the wire or cause a lot of stress on the lathe. Here's a little different view on the threading. I'm going to start the lathe up here in back gear. That's actually the speed that it's running. It's not an aliasing of the camera. I've got it in back gear. That's a high torque, low speed setting for it, and it is turning at that speed actually. And you can see that it's wrapping the wire right next to each other. I've got the carriage locked in, the half nuts locked in for threading. When I started the lathe, it started advancing immediately. If I was making a compression spring, if you ever look at a compression type spring, there's a couple of coils on each end that are right next to each other, and I would have just had the lathe run a couple revolutions before I engaged the carriage. But in this case, I want all the coils to be uniform because it's a torsion spring. So I just had it start up immediately. It seems to be wrapping really well. I measured the threads per inch on the other spring. I used a thread gauge and just treated them like threads as the wraps of the coils, and it came out to be about 18. So I've got the lathe set for 18 threads per inch, and that's what it's advancing. There, it's done. It pulled out of the tool post holder, and you can see how much energy is in that spring. I moved the live center up there because I had one of these springs when I was testing. It flew clear out of the mandrel and went flying across the shop. This stuff is pretty hard, and it's kind of hard to work with, certainly hard to cut, even with a good pair of diagonal cutters. So we'll get that cut off there, get it pulled out, and take a look at it. I think this went pretty well. You can see that the spring does kind of relax a little bit, and see how much bigger it is than that mandrel. But it'll be in the machine, in the carburetor, just like this. So, and you can see the torsion action there, and the spring winding up, and then it relaxes. So I think I'm pretty happy with this. I think this will work just fine. So here's a picture of the mandrel and kind of how it works. We saw it working in the lathe there, but there's a hole right here. That's what you push the wire through. It makes it so that it bites into the wire and will wind it up. This is the diameter that ended up making the right size spring. It comes out to be about 560 thousandths. Again, wanted the spring to be about 830 or so, and that's what it turned out to be. So it's kind of a trial and error thing on how it's going to wind. The machinery handbook has a nice table in it that kind of guides you, but it's just kind of easier just to kind of trial and error it. And here's some of the early springs that I wound just testing. Here's the first one that I tried. It sprung back quite a bit, quite a bit bigger than it needed to be, so I had to work with that. And here's another one, and then here's one when I got it finally dialed in right, and then here is the final spring. We can see here. So this one it'll be compressed down like this in the engine, and I'd left the tails long so I can wrap them around the pins and get that set right and get the right tension. But all in all, pretty good spring making video here, I think. Sorry about not having that footage for making the mandrel, but I don't know what happened to it. So thanks for watching, and in the next video I'm actually going to be making this part, which is the butterfly plate and the carburetor. I tried to kind of fill it up and stuff. It had quite a bit of rust and stuff on it. It's quite pitted, so it's just not going to seal very good. So I'm just going to make another one. So we're going to do that, and then after that we're going to end up making one of these, which is a spring lever handle. There needs to be two of them on the mixer, and I have one, so I need to make another one. So we're going to be making that as well. So thanks for watching, and I'll see you in the next video.